Basics of Chemistry. Chapter 1 Introduction to Chemistry. What is chemistry? Chemistry is the branch of science that studies matter, what it is and how it changes. Matter. Anything that occupies space and has mass. Everything you see, touch, hear, smell, and taste involves chemistry and chemicals, which are all matter. Chemistry investigates the properties of matter, how they interact, and how they change. Chemistry is like cooking. For example, when you're making a hamburger or doing any kind of cooking, you are mixing ingredients, the meat, matter, mashing, applying a force and grilling, changing the temperature until you get a hamburger, a new substance. Chemistry is everywhere. Cooking, the creation of food, how and why food rots. Cleaning, the creation and use of detergents, disinfectants, and soaps. Medicine, the creation and use of drugs, vitamins, and supplements. Environment, the creation and spreading of pollutants and the creation of materials to clean up and prevent pollution. Types of chemistry. Chemistry has different disciplines, or branches. The 5 main branches are: organic chemistry, the study of carbon-containing compounds in both living and non-living things. Inorganic chemistry, the study of everything except carbon-based compounds. Biochemistry, the study of the chemical processes that happen inside living things. Physical chemistry, the study of chemical systems as they apply to physics concepts. Nuclear chemistry, the study of chemical changes in the nucleus center of an atom. A chemical substance that has carbon atoms. The smallest unit of matter. Methane gas. Organic vs inorganic. Organic compounds contain carbon and hydrogen bonds. Most inorganic compounds do not contain carbon. Scientific inquiry. Scientists find evidence by conducting experiments and making observations. The process of using evidence from observation and experiments to create an explanation is called scientific inquiry. Scientists use a step-by-step method to answer a question. This is called the scientific method. It provides scientists with a systematic way to check their work and the work of others. Scientific inquiry begins with a question or a problem. The scientist tries to collect all of the possible information that relates to the investigation of that question by doing background research, making observations, and conducting experiments. Background research involves reviewing the findings of past scientists to create a hypothesis, a possible explanation for an observation or problem. Scientists test their hypotheses by making observations and comparing them to their predictions, guesses of what might happen based on previous observations. Observations can require using the senses way something looks, smells, feels, or sounds to describe an event. Observations can be quantitative, made in the form of measurements. They can also be qualitative, describing color, odor, shape, or some other physical characteristic. The findings of a scientific inquiry are called results. A measurement must have both a number and a unit, for example, 6 inches. Scientific inquiry answers multiple questions. No fixed order of steps. Scientific method answers one question. A step-by-step process done in the same order each time. Results must be communicated. Scientific method. Scientists repeat the steps in the scientific method until a hypothesis is proven as either true or false. RSKAQUESTIONORIDENTIFYA. Prob LEM. Con DUCTBACKG Rho UNDRESE arch crossing E8AHYPOTHESIS. Tay streak THEHYPOTHESISWITHEXPERMENTSMAKEOBSERVATIONS and decol LECT data anal YZERESULTS doctor or conclusions SHRERESULTS. If val SE, Chang EVARIABLE and DBEG in AGA in 1, 2, 4, 3, 5, 6, 7. The scientific process isn't always straightforward. Scientists often find themselves coming back to the same questions again and again. Types of scientific investigations. Scientists use pure science and applied science to conduct scientific investigations. Pure science. The search for knowledge or facts. It uses theories and predictions to understand nature. Geology is an example of pure science. Applied science. Using knowledge in a practical way. Related to engineering and technology. The development of a rocket is an example of applied science. DNDT equals RNINK. Making a model. A model is a representation of a particular situation using something else to represent it. It allows the scientist to easily observe and gather data. There are different kinds of models. Types of models. Physical model. Something that can be built, such as a molecule that is made of marshmallows, gumdrops, and sticks. Computer model. A three-dimensional simulation of a moving object or a chemical reaction. Mathematical model. Calculations involving a particular mathematical equation, for example an equation of a line. Scientific theories and laws. After completing many experiments or developing many models, scientists are able to use the results to develop ideas to explain how and why things happen. A scientific idea starts as a hypothesis that has not yet been proven to be true or false. Once a hypothesis has been proven through tests and experiments, scientists will develop a theory. Theories can be proven or rejected. They can also be changed and improved as more facts are gathered through experimentation or modeling. Theories are the basis for scientific knowledge. They are a way to take collected facts and put them to practical use. Theory. A proposed explanation that is based on an examination of facts. Facts can be observed and measured. A theory is a scientist's explanation of the facts. Theories are the basis for inventions, such as rocket ships to Mars, and research, such as finding a cure for cancer. Scientific laws describe what happens in nature. For example, the French chemist Antoine Laurent Lavoisier wrote the law of conservation of mass in 1774. This law states that during a chemical reaction, matter is neither created nor destroyed, just rearranged. Law of conservation of mass. Law. A rule based on observation of a process in nature that behaves the same way, each and every time. A LAW describes what happens. A theory describes why something happens. W. 1. What is chemistry? 2. How do organic compounds differ from inorganic compounds? 3. Name 3 of the 5 basic areas of chemistry and what scientists study in these areas. 4. What are 2 methods for investigating science? 5. Name the basic steps of scientific inquiry. 6. What are models and why are they used in science? 7. What is the difference between a scientific theory and a scientific law? 1. Chemistry is the branch of science that studies matter, what it is, and how it changes. 2. Organic compounds contain carbon and hydrogen bonds. Most inorganic compounds do not contain carbon. 3. Organic chemistry is the study of carbon-containing compounds. Inorganic chemistry is the study of everything except carbon-based compounds. Biochemistry is the chemistry of living things. Physical chemistry is the study of chemical systems in terms of the principles of physics that are used to measure physical properties of substances. Nuclear chemistry is the study of radioactivity and the decay of atoms. 4. Scientists approach their investigations either by searching for pure science through knowledge and facts or discovering applied science using knowledge in a practical way. 5. The basic steps of scientific inquiry are: ask a question, do background research, make a hypothesis, test the hypothesis, analyze results, draw a conclusion, and share the results. If the hypothesis is proven false, another step is to create a new hypothesis. 6. Models are representations of the experiment or object that allows the scientist to easily observe and gather data. 7. A theory is a scientist's explanation of the facts, either measured or observed. A law is a rule based on observation of a process in nature that behaves the same way, every single time. Chapter 2: Conducting experiments. Designing a scientific experiment.